Good morning, everyone. Fine, pleased to be among you to present this methodological work on integrating technique with the web service to smoothly developing adaptive AI-powered knowledge. For that, I will be respecting the following agenda. So I will recall some well-known advantage of AI and machine learning based software, and then some limitation on which we make or we will be focusing in this presentation. So the solution to overcome this flow will be based on software engineering technique, so to bring more agility and discipline. So the approach milestone based on this software engineering is based on 5 incremental steps, and the work will be illustrated or validated with healthcare case concerning brain tumor. And I will be wrapping this presentation with some remark and future work. So it's well known. I bring nothing here that AI and ML-based model and technique are highly efficient in terms of time. They bring auto learning or self learning. So and with the data set could go more than a human-based couple of years. So could be 100 or 1,000 of years. That being more experience, more knowledge to reason on the application. But on the other side, so there is severe limitation of ML-based software. Program, it's not really software because they are algorithmic based. So the rigidity, because they are, as I said, algorithmic based. So by essence, they are non-adaptive, black boxed. They are not based on what clear methodology as we know it from software engineering. And the most serious problem is the incompatibility of what we have been doing all these 20 or 30 years. And now that means there is a incompatibility between machine-based software and domain-based application. Example of patient, for instance, in the healthcare, there is a patient's software and there is machine learning, and they are incompatible. And this, we try to bring in our contribution, these two words together. So as I said, our solution is to recapitulate on software engineering. So first, software architecture, that means we try to externalize all interaction at the communication or integration interaction level, as known as connector. That means we try to minimize the domain entity and all functionality and rule and are at the interaction level. And we do this for both, for the domain-based application and the machine learning side. So, and this interaction, we try to express it or formalize it in a precise way using the well-known event condition action. So in this sense, we have participant attribute triggers condition to allow this action and the action to be superposed on different entities. So then we adopt service orientation. That means all our entity and component are captured as web service. We go one step further to formalize our rule with rewriting logic. That means to allow diagnostic, conflict, contradiction, redundancy, and so on. We do validation with rewriting logic on both sides. And finally, we also concentrate on the elicitation or semi-formal requirement engineering with well-known UML class diagram. So now, when we put all these concepts, software engineering concept together, we result in our approach, which is five-based application. So the idea is, if we don't need machine learning, then the process will be in this way. We have informal requirement. We try to modelize or conceptualize as software architecture, and then we validate them with rewriting logic, and we do the efficient implementation with Python and Django, for instance, but we could have .NET, ASP, and so on. So, but in the reality, so for instance, for our application Brain Tumor, so there is a case where the doctor or the medical staff could not resolve. Then they have to resort to software engineers. So if there is impossibility to resolve the problem with usual rule, then we have to resort to machine learning. And in the same way, in an architectural way, so compatible with the domain-based one. And then we validate them and we do the efficient implementation. So all these steps will be now illustrated with our brain tumor. So I am not a doctor, but by looking, so we could extract that at the UML or the class diagram. We have patient, we have doctors, and the tumor has two specific or two kind of symptoms, the general symptoms and the specific symptoms, such as balance loss, pressure, 5 sense degradation, swelling, difficulty, muscle problem. And we have the radio image, so to check if there is deficiency. This is the model, the usual model-based side that we have been doing all these 20, 30 years. What we bring new is that even at this requirement engineering phase, we enforce the AI expert to express his requirement, what he wants to implement, and so on at this, as I said, early phase. That means we assume that he wants to implement machine learning KAN algorithm, for instance. Then he has to express as entity, as component, his class diagram. For instance, the KAN ID, the test size, the number of neighbors, the accuracy, and this information, and some operation, for instance, put, get the scores, get the accuracy, and this information so will be used in our rules. On the other side, for instance, the dataset could be seen as class first at this stage, then as web service afterwards. For instance, the dataset can be cleaned as operation. We get, we put, we cleanse, and so on. So this is the new things that we enforce the AI or the machine learning expert to express as UML what he want to implement. Then this is the static side. The behavioral or dynamic side is the rules. For instance, when known for medical staff, medical or domain expert, for instance, one rule, if the patient is over 60 and he suffers from chronic antecedent and he present some general symptom, then we can say that, or the medical staff can state that he is suffering from brain tumor. And as well known, this is the medical staff, they are basing their, or medical expert, they are basing their judgment on different rules. On the other side, so the IA or the ML expert, he has to choose the best, so the best model, machine learning model. So in our case, for instance, the simplest and the efficient one, KAN, the most appropriate data set, he has to clean it, and he has to reason on the parameter, explicit parameters, such as the percent of test and training, or the number of neighbor, and so on. So now, for instance, so we have informal rule and class diagram. We put them together in architectural way. That means we have the connector, what's called the connector glue, or the body of the interaction. For instance, we have doctors interface from the web service, doctor, web service patient, web service radio image, web service general symptom. And for instance, this informal rule can be formalized in precise way. So at trigger, when doctor want to check specific patient with his information, then we test the old age. We have if he has antecedent, if some symptoms are at some level, then we can state that he is suffering from tumor status and he should be hospitalized at some level. So this is the usual domain side. Now, the machine learning side. So we have now the blue one. So the KAN algorithm with its what we need, predict, compute, and the COVID or tumor data sets, sorry. So, and here, for instance, if we want to predict, then we have first to clean the data sets, and we have to loop until we get the most higher accuracy and prediction. Then we put the result, because the KN algorithm is perceived as web service, we put the result on the web service. Then the next phase is to, is to profit from this result at the domain level. That means we combine now, we bring together, as I said, this is the focus of this contribution. We bring together the domain expert with the AI or the machine learning expert. So that means now the domain expert, he will not be based only on his judgment using the information of the patient, but from the result he get from the previous phase. That means, for instance, he want to say that the accuracy should be more than 95 to state that the patient is suffering from tumor, for instance. And this is, of course, these three steps are very flexible. For instance, depending on the institution, on the enterprise itself, if they are really involved in artificial intelligence, then we can skip, for instance, the domain sites. So if there is hospital who are based more on machine learning, then we can go directly to the phase 2 and phase 3 and so on. So there is very high flexibility in this sense. So now, as I said, we formalized these rules in terms of rewriting logic and using the configuration or the data from the web service, we can so reason on this rule. So by rewriting them and so on to check if there is conflict, if there is contradiction, if there is inconsistency, redundancy, and so on. So this is the fourth phase of the. Then the fifth phase is to implement this in efficient way. So for the web service, we are using implementing them with Django. So Django REST, and to get the result generally is in JSON or XML. That's why we have added another level which allow to bring this XML and JSON in terms of object-oriented, usual object-oriented, so that the rule will be easily formulated. So this is the fifth phase. So this is just snapshot of the call of the web service. So this is the KNN class for the web service. So to wrap this concluding remark, that we presented a methodology that bring together usual model or domain application with machine learning application in very, very smooth and soft way, and we validate it using architecture technique and rewriting logic. So what we are doing now is more case study. So not only medical, but financial, logistic, and so on. We are including more machine learning, especially deep learning, and we are also reviewing the formal validation, how to make it in systematic way to get from the rules systematically and from the web service systematically the rule and validate them. So this wrap up my presentation. Thank you. And if there is any question or thank you very much.
Thank you. Okay, any questions? No? Can I ask you?
Yeah.
Something about applications in clinics. Have you applied it already in Germany or somewhere?
Yeah, we are trying to collaborate with them. I have 2 students.
Can you hear me?
And we are just in the starting phase, let's say. So, because they have a deficiency on machine learning, and so that's why it's yeah, let's say a starting point to collaborate with them.
Sorry, can you repeat answer, because we had problem here.
As I said, we are trying to collaborate with them, so with the medical side.
Okay. Thank you. Close it. Because oh, okay, 2 degrees. Just tell me. I will. Thank you. Yes.
Okay.
No, you should be increased.
No.
Okay, just close it. You have closed yours? Okay. Okay, please just unshare, please.
Okay, thank you. Thank you.